Welcome to Spring LIB.
In this question, we have a string that is hanging over a pulley and has a mesh attached to it. The length of the string is 1.50 meter, and the linear density is 6.6 times 10 to the negative 4 kilogram per meter. And we want to know what is the mass of m so that the string can produce 1 loop, 2 loops, or 5 loops. So we can do that by looking for the fundamental frequency of the string, because when it produces 2 loops, it's just 2 times the fundamental frequency, and when there are 5 loops, we have 5 times the fundamental frequency. So the fundamental frequency, Fn, it equals n times, so any frequency equals n times the fundamental frequency. Fundamental frequency F1, it equals V over lambda 1. But at the same time, because F equals V over lambda, but at the same time, we know that for the most fundamental first harmonics, lambda equals 2L. So we have F equals NV over 2L. Now, since it's a transverse wave on a string, we also have this relationship for V, that V equals Ft over mu. And Ft equals mg. So this is a formula we have. And we can see that we have everything we need except m. So we can rearrange this equation so that we have m equals, for L squared, Fn squared mu over n squared g. So for Fn, we know that the mechanical oscillator over here has a fixed frequency of 120 Hz. So for part 1, when we only have 1 loop, that corresponds to n equals 1. So n equals 4 times L squared times 120 Hz squared times mu is 6.6 times 10 to the negative 4 kilogram per meter. N squared is 1, g is 9.80 meter per second squared. So this is 8.728 kilogram, which is roughly 8.7 kilogram. For part B, we do not actually need to go through the whole calculation because we can see the only thing that's going to change is n. So in order to have 2 loops, m goes from 1 to 4, so m2 is 1/4 of m1, which is 2.2 kilogram. Same, m5 equals 25 times m1 because we go from 1 loop to 5 loops. That is 0.35 kilogram.